We're asked to find the two smallest positive angles that satisfy the following condition. Cotangent A is greater than 0, and the reference angle for angle A is equal to 0.9124 radians. On the coordinate plane, cotangent theta is equal to x divided by y, and since we know cotangent A is greater than 0 or positive, we know that both x and y must be positive, or both x and y must be negative. Remember, a negative divided by a negative is equal to a positive. And therefore, angle A must terminate in the first quadrant, where both x and y are positive, or the third quadrant, where both x and y are negative. And since we're looking for the two smallest positive angles that satisfy the given condition, the angle that terminates in the first quadrant has the initial side along the positive x-axis and the terminal side in the first quadrant, and this would be the least possible positive angle. And this angle has a reference angle of 0.9124 radians, but because this angle is in the first quadrant and is an acute angle, this angle is the same as the reference angle of 0.9124 radians. So the smallest possible positive angle that satisfies the given conditions would be 0.9124 radians, and the second smallest positive angle that satisfies the condition would terminate in the third quadrant, and therefore it would have the initial side along the positive x-axis and the terminal side in the third quadrant. And again, because we're looking for now the second smallest positive angle, the angle would have to be this angle here, where the reference angle is 0.9124 radians, which is the angle between the terminal side of the angle and the negative x-axis, this angle here. So the second smallest positive angle that satisfies the given conditions would need to be pi plus the reference angle, or pi plus 0.9124 radians. Before we go to our calculator to determine this sum, if we take a look at our notes below, if angle A is between 0 and pi radians, and angle A terminates in the first quadrant, angle A is equal to the reference angle, which we found as our first angle, and if angle A terminates in the third quadrant, angle A is equal to pi plus the reference angle, which we have here, which will now determine the sum accurate to 4 decimal places. To 4 decimal places, we have 4.0540. I hope you found this helpful.